In this video, I'm going to go into more detail about the standard error of the mean, or what we're just calling the standard error. And this will be a little bit longer of a video because we're going to do some good learning checks. The math is not hard in this, by the way. We're going to do standard error. We're going to talk about standard error and its relationship to sample size and population standard deviation. So two very important factors with standard error. We'll talk about the relevance of standard error as well. So standard error measures the average distance between a sample mean and the population mean. And basically it amounts to the difference we would expect from one sample to another. And it can be computed for any sample size that we're talking about. So standard error is so valuable. It measures precisely how a sample mean estimates the population mean for any given sample. So we have a new formula for standard error. Here it is. It's basically the population standard deviation divided by the square root of the n. So it's determined by two factors. Sample size is in the denominator, the square root of the n, and in the numerator is the standard deviation of the population. These two things together, the relationship between these two things, determines the standard error. The first factor is sample size, and sample size will determine how accurately the sample represents the population. It's also a parameter of the distribution of sample means, and in general, a rule to follow, a large sample should be more accurate. So the larger the sample size, the smaller the standard error, and we're going to look at this. And this is due to something called the law of large numbers. You don't really need to know anything about that, but I thought I'd throw that in there. So larger sample sizes equals smaller error. So here's some illustration of what this means. And this, you will remember the first illustration from lesson 6. So we have the distribution of the means. And if we only have one mean, the standard error is going to equal the standard deviation for the population. And we're going to illustrate this more with some numbers, but just keep this in mind that the standard error, if we only had one mean that we're talking about, the standard error is going to equal the standard deviation. However, if we have an n of 4, our standard error goes from 20 to 10. So our standard error decreases when we have more people in the sample. You might say 4, it's not really a big sample, but even then, it changes the error. It decreases the error amongst our means. And finally, in picture C, we show an n of 100. Oh my gosh, the standard error goes all the way down to 2. So what this illustrates is large samples have smaller error, and small samples have larger error. This is just something to kind of drive home in your head. If I have a large sample, it means I have smaller error. And if I have a small sample, it means larger error. So standard deviation is another part of this. So we just talked about sample size, what that has to do with it. But standard deviation impacts our error too. It's part of the equation, the numerator, I should say. So standard deviation represents the spread of scores from the mean as we talk about standard deviation. So a small standard deviation means that the scores are clustered very close to the mean. A large standard deviation means that scores are farther from the mean. So when we have an n of 1, then the standard deviation, or the standard error, is equal to the standard deviation. We've talked about that. So thus a smaller standard deviation is going to result in a smaller standard error of the mean. So if our standard deviation is smaller, it results in a smaller standard error. So it's probably much easier if we just kind of map all this out. So we're going to do a couple of learning checks here. We're going to have a population with a standard deviation of 20. And I want you to pause the computer, try to work this out using the formula for standard error and figure this out. If we have a single score, how close on average would you expect the score to be to the population mean? In other words, figure the standard error. Then figure the standard error if we had a sample of 4 scores and a standard deviation of 20, 25 scores with a standard deviation of 20, and 100 scores with a standard deviation of 20. Pause the computer, come back, we'll work it out together. And don't skip this step. You might be just saying, oh, I'm not going to do it. But if you don't do it, you don't have practice with struggling and working it out. So I'm going to encourage you to stop the computer and try to find the standard error for each of these 4 scenarios. So for this first learning check, we have everything we need on the board. We knew that the standard deviation of the population is 20, and the formula for standard error of the mean is the standard deviation divided by the square root of n. So we can do this very easily for all of these. So for the first group, we have an n of 1. We take the standard deviation of 20, divide it by the square root of 1, which is 1. So for an n of 1, the standard error of the mean is 20. Now we have an n of 4. We still have the same standard deviation of 20 divided by the square root of 4, which is 2. So the standard deviation for an n of, or the standard error of the mean for an n of 4 is going to be 20 divided by 2, and now it's 10. So already our standard error is going down with the larger sample size. The third scenario is an n of 25. So I'm going to take the standard deviation of 20 divided by the square root of 25, which is 5. So 5 goes into 20 4 times. Now our standard error has gone down to 4. And finally, we have an n of 100. So I start with the standard deviation at the top, divide it by the square root of 100, which is 10. 10 goes into 20 2 times. Wow, are you seeing a pattern here? With the sample size increases, the standard error is doing what? Let's take a look. And in sum, this is what we just figured out. We have a sample of 1. We had 20 points, or a standard error of 20. When we have 4 scores, we had a standard error of 10. 25 scores, we had a standard error of 4. And 100 scores, we had a standard error of 2 points. So what does this tell us? This tells us as our sample size increases, our standard error decreases. Okay, we're going to try something different. In this example, we're going to take a standard deviation for the population of 10. In the last examples, our standard deviation was 20, and this time we're going to figure out the standard error when our standard deviation is 10. Same situation. A, you have 1 score. B, you have 4 scores. C, you have 25, and D, you have 100. Figure the standard error using the standard deviation of 10 in your standard error formula. Pause the computer, figure it out, and then come back. For this next learning check, we have everything the same except for our standard deviation of the population, which is 10. So I'm going to figure out the standard error of the mean for each of these different sample sizes. We'll start with a sample size of 1. We take the standard deviation of the population 10 divided by the square root of 1, which is 10 divided by 1, which means our standard error for an n of 1 is going to be 10. It's equal to the standard deviation with an n of 1. So with an n of 4, I'm going to start still with the standard deviation of 10. I'm going to divide by the square root of the n, square root of 4, which is 2. 2 goes into 10 5 times. So our standard error of the mean for an n of 4 is going to be 5. When we have an n of 25, we're going to start with the standard deviation of 10 divided by the square root of 25, which is 5. So 5 goes into 10 twice. So now we're down to a standard error of 2. Amazing, right? So our last one is an n of 100. We start with the standard deviation of 10, divided by the square root of the n. The square root of 100 is 10. 10 goes into 10 1 times. So our standard error of the mean for an n of 100 is 1. Okay, so when we had a standard deviation of 10, and we have a sample size of 1, we had a standard error of 10. With a sample of 4, we had a standard error of 5, 25 a standard error of 2, and 100 a standard error of 1. So the same pattern is seen here very easily, that when your sample size increases, your standard error decreases. But let's take a look at both of these checks that we've done side by side. So on the left, we have a standard deviation for the population of 20, and on the right, we have a standard deviation for the population of 10. So the pattern holds, as you can see, that with the sample size increases, the standard error decreases from top down. But also look from left to right, that as our population standard deviation decreases, our standard error also decreases. So for example, when it was a standard error of 20, we went from 20 points for a sample of 1 to 10 points with that same sample of 1 when we had a population standard deviation of 10. You might want to just percolate on this just a little bit, just take some time to think about it. So factors related to standard error. Large sample sizes more accurately represent the population. And standard error decreases with larger sample sizes or larger n's. And standard error also decreases with a smaller standard deviation. This is what we've been talking about this whole video. These are the things to remember. What influences standard error? Sample size and population standard deviation. There you go. Here's our last learning check, which really puts together everything from the last few videos. A population of scores is normally distributed, keep that in mind, with a mean of 80 and a standard deviation of 20. I want you to describe the distribution of sample means, the DSM. Talk about what shape it takes. Talk about what is the measure of central tendency and what is the variability for 2 different scenarios, one with an n of 16 and one with an n of 100. So you're going to figure all that out. Then you're going to answer one question. How did the distribution of sample means change when the sample size increased? Okay, pause the video, work this out, come on back. So here we go. For scenario A, we had n of 16. The shape of the distribution, the DSM, is normal. How do I know that? Well, I did mention that the population was normally distributed. And when we know that the DSM is also going to be normally distributed. So we're good. The expected value of the mean is 80. How did I know that? Well, the distribution of sample means, the mean of that, is going to be equal to the population mean. And I already told you that the population mean was 80. Now, the last thing you did actually have to calculate, and that's the standard error of the mean. So we had, I'm going to click back here, a standard error of 20, or a standard deviation of 20, excuse me. So we have 20 divided by the square root of the n, which is 16. Square root of 16 is 4. 20 divided by 4 gives us a standard error of 5. The standard error of the mean is 5. Okay, A is done. Now B, we had an n of 100. So what is the shape going to be? Well, we have 2 ways of knowing that the shape is normal. First of all, I already told you that the population was normally distributed in this scenario, so you knew that. But also you know that the distribution of sample means is going to be normally distributed because we have an n of over 30. So good, we're normally distributed. The expected value of the mean for the DSM is 80. Again, for the same reason. It's going to be the same as the population mean, which I gave you in this scenario. And finally, the last thing you're asked to do is the standard error of the mean for this scenario. So the standard deviation again was 20, and that's 20 divided by the square root of n. The square root of 100 is 10. 20 divided by 10 is 2. So our standard error is 2. So let me go back to what that last question asked. How did the distribution of sample means change when the sample size increased? Well, the shape was exactly the same. The expected value of the mean was exactly the same. But only the standard error decreased, and it did so when the sample size increased. All right, that's a lot of information for you at this time. So in our next video, we're going to be applying the standard error formula to z-scores and probabilities. So I'll see you there.